Welcome, everyone. I would like to thank you for joining my talk and the organizers for the opportunity to speak to you. It's my pleasure. My name is Oksana Riba Grognuz. I'm a senior data science engineer at the Swiss Data Science Center, and I'm delighted to share with you how our collaborative platform Renku helps to democratize reproducible workflows to streamline value from data. Let me start with my story to explain you why I am eager to share this with you. During my life science research years, I came across an inspiring Nature publication in single-cell omics. I immediately felt that this would be a game changer for my own research. Authors have openly shared their codes on GitHub, submitted data to archives, and described each step of the analysis for parameter settings and software dependencies. It took me several weeks to make all components work together on my computational environment, but just to realize that I couldn't validate if this computational workflow functioned properly, as I lacked one table that wasn't available on GitHub or data archives. Then it took me another couple of weeks to reach out to the research lab of the authors only to find out that the postdoc, who was the first author, was already gone, and no one else knew where the missing table was. And I didn't feel discouraged and spent another couple of weeks tracing where the postdoc was, and bingo, I could finally connect with that person. Unfortunately, I discovered that the table was not findable anymore. The postdoc has put a lot of effort in making his research available and reproducible, but somehow that file disappeared from the to-do list. Every week of such delays in academic or industrial data science projects costs time and money. At Renku team, we understand that under the pressure of daily priorities, we frequently lack time to run the extra mile needed to make our work fully computationally reproducible. That's why, with Renku, we aim to democratize the reproducible workflows, make them easily accessible for every scientist to enable continuous value generation even after project completion. In my talk, I will explain what is a workflow and how to make it reproducible. I will show how Renku facilitates the use of workflows, and then I will explain what is Renku and where we can find it. What is a workflow? A computational workflow is a process transforming data to value by turning it into a data product, service, business insights, or research knowledge. This process orchestrates multiple tasks required for data collection and preparation, feature extraction, modeling, parameter-driven simulations, visualization, or comparison to a set of standards. Workload tasks represent an execution of a computational process, such as running custom scripts and plugins, using APIs to access an external database to fetch reference data, invoking a command line tool, using pre-trained models, applying validation rules, calculating metrics, and exposing results on a dashboard. A complex computational workflow involves an entire ecosystem of tools, scripts, plugins, applications, and even another workflows. If we define our workflows using scripting languages such as Python or Bash, we risk lacking portability, flexibility, and interoperability. And frequently, this results in overcomplicated processes. Think about monitoring a progress of a 10-step workflow on just thousands of files and re-executing failing tasks. The pipeline should be smart enough to attempt the re-execution of the failing step and all the following steps. And what about workflows with more steps? To address this complexity, numerous workflow systems have emerged to offer automation, portability, and reproducibility. On the other hand, we have multiple ways to write a pipeline using scripting languages, making it difficult to reuse the underlying tasks in a different workflow. But using a workflow language, we can create standardized task modules that can be flexibly assembled into a new computational workflows. But this comes at a cost. On one hand, there is a learning curve to start with a new language, and depending on a skill set and the size of the team, it can take some time to adopt new ways of working. On the other hand, workflow systems have exploded in recent years. CWL, Whittle, SnakeMake, Nextflow, with over 295 systems already available. With so many options, the choice becomes complicated and can lead to decision paralysis. If you decide to use one system, will that be the best choice? The choice that outlasts the rest? And what if the other systems innovate faster? Barry Schwartz introduced the concept of paradox of choice in 2004. it is hard to take decisions with too many available alternatives. And we tend to push hard decisions to tomorrow and risk decision paralysis, delaying the project and translating to costs that will be higher for more complex projects. With Renku, workflows are easy. There is no need to make a hard choice with Renku. Renku uses knowledge graph to represent computational workflows and capture the relationship between data, code, parameter settings, and environment within and across projects. With this abstract workflow representation, Renku serves as a layer connecting to other workflow systems. We can update and rerun entire workflows or reuse any of workflow steps using Renku as a workflow system. And whenever needed, we can use other workflow systems by serializing knowledge graph representation to the respective workflow language. At the moment, Renku supports the common workflow language, CWL, but the same methods used to create CWL files can be extended to other workflow languages, such as Nextflow, SnakeMake, or Workflow Description Language. And there is no need to learn a new workflow language with Renku. Renku automatically records each step of the analysis by tracking user input. So instead of learning a syntax of a new workflow language, we can focus on developing the best data science and let Renku track our exploratory avenues. Renku captures the provenance of the analysis process by connecting version data, code, and environment specifications on the knowledge graph. Every command that we choose to track will constitute a task in a recorded workflow template with a range of metadata properties. We can easily rerun the whole workflow or individual tasks on the new data or with different parameter settings. Renku keeps track of every execution of workflow template and the underlying tasks. At any moment, we can identify the sources of all important elements even if they span multiple projects or originate in external public repositories thanks to research artifact cross-linking through the Renku knowledge graph. To use Renku as a workflow system, we need to know only 3 magic words displayed on your right. Renku run, to activate tracking of the executed command. Renku rerun, to reproduce a given result by rerunning all tasks used to generate it with the same or different parameter settings. And Renku update, to update the whole workflow upon changes in data or code. Furthermore, Renku knowledge graph workflow representation reduces code base up to 70%, making it modular, reusable, easier to test and maintain. On this slide, I'm showing an example of code brought to Renku that was refactored to leverage knowledge graph representation of workflows and automatic provenance. The code blocks in the center shrink to a much smaller version on the right, with respective features highlighted in both versions. What is Renku about? Renku is a knowledge infrastructure that accompanies a data scientist throughout all stages of research lifecycle. Knowledge graph at its core connects all other components and links version digital objects within and across collaborative projects. Starting from the project planning stage, we can leverage the Renku knowledge graph to maximize data to value by reusing the existing data and processing pipelines, to evaluate the required effort, and to estimate the ROI. Next, at data preparation stage, we can enable transparency and reproducibility by bringing data to versioned Renku containers linked to the data source, where Renku will automatically track changes in data contents and properties. To explore the data, we can use any of Renku flavors for interactive sessions and use custom templates to automate and standardize preprocessing steps for all collaborators. Then, rather than putting an extra effort to ensure the reproducibility of the final solution, we can leverage automatic provenance tracking for every model that we build on Renku. We can also extract and register machine learning model properties using Renku MLS plugin. Version control is vital in reproducibility since it helps track changes we or our contributors make to the project's code and documentation. Versioning ensures that every contributor has access to the latest validated code. By automating knowledge graph queries, we can continuously validate methods and results against a set of standards. Codes with all their dependencies are packaged in self-contained version containers that make Renku projects portable and reproducible across different systems and infrastructures. Finally, by activating automatic tracking, we can transform our commands to workflow templates that can be shared and reused on a different content and with different parameter settings. All the steps that I mentioned on previous slide are easy on Renku. Each of us has own preferences and favorite tools. With Renku, we can achieve full computational reproducibility using tool stack of our choice. We can manipulate datasets and work on Renku projects in web app or from command line. We can build the environment from the existing flavors of interactive sessions such as Jupyter Lab, RStudio, VS Code, or Virtual Desktop, or create our own flavor with desired dependencies, annotated metadata, and pre-configured automation. When we create a new Renku project, we simply select the desired template from the list of maintained Docker images with different flavors of Renku interactive sessions. Renku will monitor template status and inform us when the new versions become available. Updating our project to a new template is as easy as a single click in Renku web app, without overhead for local support and operations. In a nutshell, Renku consists of 3 clients coupled to a range of supporting services with custom microservices providing the glue. In the top panel, we see the clients consisting of web user interface, interactive sessions, and command line interface that connect to supporting services through Renku Core, Notebook Service, Knowledge Graph, and API Gateway. The supporting services consist of GitLab for Renku project repository management, Jupyter Hub for interactive session management, Keycloak, used for authentication, GraphDB Jena, storing the Renku knowledge graph, and PostgreSQL relational database for GitLab, Jupyter Hub, and Keycloak. Server components are deployed on Kubernetes cluster on the top of OpenStack switch engines for virtual machines, storage, and network. And there is no vendor or technology lock-in for the user except for Docker and Git, which are here to stay for a while. Why is Renku different from other collaborative platforms? Renku is a feature-rich platform providing command line interface, platform, and service for community as outlined on the x-axis that supports users for code and data versioning, environment containerization, and workflow execution shown on the y-axis. There are other platforms that cover the same range of features such as CodeOcean, Pachyderm, Terra, or Wholetail. The uniqueness of Renku relates to its knowledge graph that connects versioned digital objects, tracks provenance, and workflow execution. Users populate the knowledge graph through their actions by creating datasets and annotating them with keywords, by constructing workflows, by using domain-specific plugins that can extend the basic metadata model for specific uses. Renku Knowledge Graph creates an ecosystem with linked data not only inside a given project, but also across projects and even Renku instances. 2 Renku Knowledge Graphs can be simply joined together. The Knowledge Graph is accessible from command line and platform and is actively developed to address the needs of scientific community. This schema illustrates the main idea behind the Knowledge Graph on the example of interactions, use, and create, shown in violet and pink respectively. This toy graph shows that our collaborator used data annotated with a range of properties such as author, keywords, and format, and a machine learning model indicated with the violet arrows on the left side, to create a workflow that generates new data, which is indicated with a pink left to right arrow in the middle. In our turn, we use this newly generated data and have another model in our own workflow, indicated with 2 violet arrows on the right. How can Renku help your research? Most exploratory avenues lead to a dead end. From those that have a result, only a handful will bring enough value to result in a scientific publication or go to production. Finding this can take a long time, and here Renku can help by accelerating the failed try cycle with automated provenance tracking, reusable components, data, and environment versioning. By tracking every exploratory avenue, Renku allows us to reuse bits and pieces of different steps to eliminate failing hypotheses faster and focus on exploratory avenues that create value. Furthermore, once ready with the final solution, we do not need to take any extra steps to ensure its reproducibility. Reusable and reproducible workflows are new standards across many disciplines that rely on data science. However, creation of such workflows often requires mastery of their workload language. With Renku, we do not need to worry about this, as it captures workflows from our input, allowing us to focus on delivering the best possible data science solution. Renku connects workflows with the metadata for the underlying version components, code, data, environment, thus ensuring that workflows are findable, reusable, and reproducible. For those of us who deliver solutions for highly regulated domains, compliance can be a big burden. Already with automatic provenance tracking on Renku, we enable data and code audits. With Renku Knowledge Graph coupled to GitLab CI/CD component, we can go one step further and set up a continuous self-assessment against a set of standards and focus on delivering that solution that will be compliant by design. Benchmarking systems are another great case illustrating the advantage of coupling the GitLab CI/CD with Renku Knowledge Graph for cross-project workflow automation. In this example, I am showing an implementation of modular and extensible community benchmarking system for computational biology methods on Renku by Robinson Lab from University of Zurich and Swiss Institute of Bioinformatics. In many areas of biology, new methods appear so quickly that by the time these are benchmarked, the results are already obsolete. With Renku, we can apply CI/CD to community benchmarking by putting in place templates for modular and extensible components for benchmarking datasets, computational method workflows, and evaluation metrics workflows. Each template is pre-configured for automation and annotated with the right metadata to allow for flexible component connection throughout the knowledge graph. Thus, the format and annotation of the datasets trigger the application of compatible method workflows through scheduled automated knowledge graph queries. Similarly, methods link to metrics and then to the dashboard. Community of method users can interactively evaluate the methods on different datasets with custom method rankings and pull any of the components that are packaged with dependencies and metadata to be reproduced, reused, and integrated on other platforms. This slide illustrates such cross-repository knowledge graph linking research objects. On the left, we have two benchmarking datasets in versioned Renku data containers that contain files indicated with the edges named as part. Each dataset is connected to the repository with the data preprocessing workflow indicated with the edge used by that produces normalized output data linked with the edge has output. The normalized data is used by method workflows that produce results in one or several formats indicated as format A and B, which are then used by corresponding evaluation workflows that apply evaluation metrics to method results, with evaluation workflow 1 using results in format A and evaluation workflow 2 using results in format B. The results of both evaluation workflows are then used by the dashboard. If you got curious, I will share with you where you can find Renku and how you can reach out to us. Renku is provided by the Swiss Data Science Center as PIPEX module and is open source on GitHub. We also provide a free community service available at renkulab.io. To fine-tune Renku to specific needs, we deliver custom institutional deployments in a range of flavors, such as software as a service, cloud, and in-house deployments. With this, I thank you for listening. You are welcome to reach out to Renku community and Renku team at Discourse, Gitter, and GitHub, or connect with me on LinkedIn. You can see the barcode on the right. Thank you.